Hey everyone, welcome back. This is Dr. Kolodnicki, and today we're talking about multiplying binomials with grids. Slightly different from what we did the other day with visuals, but we are going to review that a little bit right now. So I want you to you can either draw it out on paper right in front of you. I'm going to have you draw it anyway, or you're going to use your digital algebra tiles. I want you to set up this following product. And again, just to get us started here, if you're going to get started with the algebra tiles, remember we usually put one horizontally and one vertically. Again, order doesn't matter when I'm multiplying. So I'm going to start with this 1x, and that would require a green tile. And then I have -1, which would require one of those tiny little red squares right next to it. So again, x minus 1, that's that whole expression. And then down vertically, again, lining up just the corners to leave that space in between, I'm going to have two x's lined up, and then +3, so I'm going to have 3 small yellow positive squares down here. +3. 1, 2, 3. And then again, what your job is to try to do is to fill in this space. Oof. And we kind of compared finding a product to an area. So I want you to fill up this area with algebra tiles. I'm going to use the interactive ones, and I'm going to come back and draw it in here. So if you want to do the same thing, you might want to pause the video and do the interactive ones, or do the interactive ones with me. That's fine. Alright, so we're back. It looks a little neater now, right? Because I use the algebra tiles. So x minus 1 across the top, 2x plus 3 down the left side, and then I kind of formed this sketchy gray rectangle. Again, if you want to draw the lines in, if that's helpful to you, just recall that we're going to go straight down from each one of our bars, as straight as I can make that line. That's pretty straight. And again, just to form kind of the grid where my other tiles are going to then fill in. I'm going to copy this. Let's see if I can just paste it in. I think I can. I need one here, and one here. Look at that. I feel like I'm getting better at this. Alright, so now as you can see, I'm going to need 2 squares, but then depending on the sign will depend on what, if I need a positive square or a negative square. Since this is positive and this is positive, positive times a positive is a positive. So I'm going to put a blue square in that first square. Again, a positive and a positive, another positive square in here. I'm going to continue down. I see a positive green and a positive yellow. So that will also make a positive green. I'm just going to rotate that so it will fit in that square, and I'm going to need 3 of them. So I'm just going to copy paste real quick. 1, 2, and 3. Again, we're just filling that area in. Now over here I see a positive times a negative. This is when I know I need a negative squared. So I need a negative x here and a negative x here, because again, a negative times a positive. And then again down here I have a negative red square times a positive yellow square to get this square here, and it's end up going to be 3 red squares to fill in the positives. Okay, we're going to go back to the worksheet to finalize and simplify this final answer. Remember, the answer is only the algebra tiles that fit inside, so technically if I move this away, right, this was just to set up the problem, and this stuff that's left over in the rectangle is going to be my final answer. Alright, let's go and figure it out, and we'll draw it in on our worksheet. Okay, so really quickly what I did is I kind of drew in the algebra tiles that we used to fill in the area or the rectangle space. And now I'm going to do a head count. Notice I only labeled things that were inside the rectangle, not these outside border pieces. So, final answer, I have 2 positive x squareds. I have some green x's. I have 3 of those. Those are positive. I also have 2 negative x's. And then I also have 3 negative 1s. And if you recall, technically this is not simplified because I have like terms. Can you spot the like terms in here? Yes, I have this 3x and I have a negative 2x. I'm going to combine those together. Again, just adding the coefficients, 3 minus 2, and I get 1. So I can write 1x, or I could just write x. And this is going to be my final answer. Again, just a review of the use of the algebra tiles. We're going to do the same exact problem, except we're going to use a grid. It's going to be a little bit different. We're going to need our calculator. So pause the video if you need to copy this down, and then we're going to go to the grid. Okay, so we're going to do the same exact problem, and I'm going to rewrite the problem up on top just so that you remember what it was. It was x minus 1 times 2x plus 3. And I'm going to show that, and we're going to organize that using grid instead. Again, it will save us a little bit of time moving away from the physical tools that we've used to a more representative or graphic representation of what we just did. So we had the x and the minus 1 on top, if you remember when we drew it, and then we had the 2x and the positive 3 on the side. So again, I'm going to just kind of separate each term. So x goes in its own box, the minus 1 goes in its own box, the 2x goes in its own box, the 3 goes in its own box. And now what I'm going to do is I'm going to use my rules for multiplying binomials. If you remember, when we multiply a binomial, I'm sorry, not a binomial, a monomial. When we multiply a monomial, we multiply the coefficients first, and then we use our rules for exponents, and when we're multiplying we're going to add our exponents. So just a kind of a refresher from a few lessons ago when we talked about multiplying and dividing monomials. So I'm going to start, and I'm going to use the box to help me to find the intersection of those 2 points. So I'm going to start with 2x times x. I'm going to fill in this box right here. So really, again, what I'm doing, and I'm going to write it really small, is I'm doing 2x times x. So first I multiply the coefficients. Since there's not one here, I'm going to put a 1. So 2 times 1 makes 2. Let's make that a brighter color. Let's make it like green. So my answer is going to be 2. And then x, again, no exponent. I'm going to put a little tiny 1 up here and a little tiny 1 up here. Add the exponents, so a 1 plus another 1 would make a 2. So it's going to be x to the second power. Okay, so we're going to do 4 tiny problems in one problem. So I just did 2x times x. Again, written in red just so you can see what we're doing. I'm going to do the same thing over here. This time we're going to do 2x times a negative 1. So again, if I have coefficients, I'm going to multiply those together first. 2 times negative 1, and I'm going to get negative 2. I do not have exponents to add. I don't have any exponents here at all. I don't have a variable, so I'm just going to rewrite the x next to it. So negative 2x. Now, do you recall, right, when we had that visual, there were 2 blue x squareds. On our visual, there were 2 negative x's, right? So the visual and our grid is going to match up. Moving over to this box. Again, I'm going to multiply the 2 boxes that intersect it. So I'm going to multiply 3, or positive 3, times x. And again, I'm going to multiply coefficient times coefficient. Since there's not one here, I'm going to put one in here. 3 times 1. And I'm going to get 4. Not 4. Whew. 3 times 1 is 3. I'm going to get 3. And then I'm going to multiply or add the exponents, but since there are no exponents to add, I'm just going to rewrite with an x. Do you recall there were 3 green x's on our visual, right? So everything is matching up. Now finally, my singles, right? These are our constants. I have a positive 3 times a negative 1. Positive 3 times a negative 1. I'm using parentheses just to clarify those symbols. And these I can just multiply together. What is 3 times negative 1? It is negative 3. Do you recall we had 3 negative boxes, right? So now what we're going to do, and I'm going to draw your attention by drawing a big blue box around this. Again, this is our answer right here in the blue box. And what we're going to do is we're actually going to combine. Do you recall this? We wrote this. Do you remember? We wrote this up at the top. And all I did was I just rewrote the 4 answers, right, horizontally. Do you recall also we had to combine the like terms? I'm going to do the same thing here. And notice my answers are exactly the same. The final answer is the sum of the interior boxes. What do I mean by interior? I mean the inside boxes. And then if you notice, and this will be a pattern that you'll notice throughout as well, is when I combine, the like terms I'm going to have to combine are going to be across from each other, like this. And you're going to see as we get larger and larger, they're always going to be diagonally across each other in this way, from like bottom to top, like that. All right, so make sure you have all this copied down, and I'm going to see you in class, and we're going to do some more grid multiplying.